Hi everyone, this is Miss Folly. This is a recording video to explain how to answer the questions from your tutorial 8, which is nuclear physics. Now I will not discuss the whole questions, but I will select a few number of questions to discuss in my video. And I will start from the questions number 5, and I will skip questions 1 to 4 as I know and I believe you will be able to find the questions, the answer of the question or the explanations of all the questions from any website or any video. So please make an effort to understand the questions from first to fourth. Now this is questions number 5. So I have an isotope here, which this isotope is krypton, and I was given the half-life of this isotope, which is equal to 3 minutes, and I was given the original samples or number of samples or number of activity for this krypton is equal to 1280 count per second. So this is my R0, and this R0 was count at 3 p.m. So the original time is 3 p.m. At 3 p.m. the number of activity of this isotope is equal to 1280. So it has half-life of 3 minutes. So after 3 minutes, supposed to be the number of activity of this isotope of this krypton is supposed to be half of 1280. So the first question asks you to determine whether the number of count per second will be increased, decreased, or remain the same. Well, obviously it will be decreased, right? So because this is nuclear, and you know that after half-life the number of counts of this count supposed to be half from the originals. So the answer is decreasing. Now B, you were asked to find how many count per second would you expect to observe after half-life. So I will start from this equation. R is equal to R0 exponent of negative time divided by the decay constants. So the R here is the number of counts which I need to find when T is 3 minutes. Remember, I need to find the counts after 3 minutes because it was asked after one half-life has elapsed. And then the R0 here, which is the original number of this krypton before it is goes here with half-life, is equal to 1280. So this is the R0 is 1280 count per second. And then exponent with the negative t here, which is our time. So I was asked to find after 3 minutes, which is after half-life. So the time is 3 minutes here, over with our decay constant. So I don't have this one, but then I can calculate it through half-life, because half-life said that because half-life said that half-life over with the time constant is equal to ln 1/2. So this is the relations between my half-life and also my decay constant. So by substituting the half-life, which is 3 minutes, and then calculate this one, you will gain your decay constants. So your decay constant supposed to be is equal to ln half. So this one is equal to ln 0.5. Now substituting, you already substitute everything, calculate it through your calculator, you're supposed to get the new number of count after 3 minutes is equal to 640 count per second. So this is the answer for B. Now, question C asks you to determine the number of count per second produced by this sample at 3:50 p.m. So this one is after 3 is equal to 15 minutes. So the similar equation will be used to solve question number C, which I will write it over here. So I will start from here, but then my T is supposed to be equal to 15 minutes because I need to find after 15 minutes, because I know at 3 p.m. the number of count is equal to this one. So after 15 minutes, what happened to it? So just substitute over here. R0 is similar, which is 1280 count per second. Exponent of the 15 minute over here is 15 minute because the equation state this is for T, so this is 15 minute over with the ln 0.5 because the number of constant for krypton in this case is similar, whether it is after 5 minutes or after 15 minutes or after 30 minutes. So the number of decay constant still similar with the originals one, so I can still use ln 0.5. By substituting everything and substitute into your calculator, you're supposed to gain this answer, 40 count per second. So this is the answer for question C. Now that's it for questions number 5.